Hello and welcome back. In today's video, we will dive into building classification model using k-nearest neighbor algorithm. If you missed our previous video where we explored logistic regression algorithm, be sure to check it out. For this tutorial, we'll be working with Iris dataset. Okay, so I'll leave the link down below. You can just click on it and it will navigate you to this page. Once you can download the dataset right here. When you download it, kindly save it in the working directory of your Jupyter notebook file you'll be working with. Okay. So once you are done with all this setup, then we can get started. Alright, so let's start. So we'll be going through 8 steps, okay? And the first step is to import the necessary libraries. So I'm just going to paste them here, okay? So the first one we are going to import is NumPy. We're going to import pandas, joblib for saving our model. We also import train split or train test split. We import standard scalar, k-nearest neighbor classifier, accuracy, score. We also import confusion matrix and classification report. Okay, so we can now run this by just clicking on the run button, and after that, the next thing we have to do is we have to load our data set. Okay, so I'm just going to load it using pd, then read. So you can just tap on the tab, then CSV. Okay, so here you have to provide the name of our data set. So you can just come here and then copy it. Okay, so you have to copy everything and you have to paste it right here and run it. So now we can create another cell beneath, and let's take look at our data set. So this is how our data set looks. It has 1, 2, 3, 4, 5, 6 columns, right? Which is ID, SELPA, length, SELPA width, petal length, petal width, and then species, right? And with this data set, this is how we want it. We want to use these columns, okay? So these columns to predict our species, okay? And from the look of things, ID won't be necessary or won't be needed. So we have to drop ID and then focus on the rest of the columns, okay? And then, so the next thing we can do is split our data, all right? But before then, we can also check some information as well. So you can just click on info, all right? And then as you can see, we have 150 entries here and we have 6 columns, right? And these are the columns, the count, and their data types. So since all the counts are 150, then it means we don't have any missing data. So we can just go ahead and split our data. So what I'm going to do here is data dot drop. Okay. So here we are going to drop some of our columns. All right. Let me just send this one back. Okay. So as I explained earlier on, we have to drop this. Okay. And then this. So these four are going to be our input. All right. So S. So we have to drop species. So this one, let's copy that. Oops. Let me copy this. So you're going to drop this and then also ID. Okay. Mm, as this plus one. Okay. And then for our Y, which is our output, we will just select the species. Okay. So that one too is going to be data. You have to specify our species here. Okay. So let's run this and let's take a look at how it is. So I'm going to create a new cell down below and let's take a look at our input. Okay. So now our input is SELPA length, SELPA width, petal length, and petal width, right? So these are features. Okay. And let's take a look at our column. Okay. So our output is the species. Okay. Yeah. And now we can now split our data into training and testing. So I'm just going to say x underscore train and then x underscore test, y underscore train, y underscore test. Okay. So here we're going to use the test train test plate. Okay, so I'm just going to call it right here. And here you have to pass in our x and y values, which is our features and then our column or our label. Okay. And we also have to specify the test size. So test size of 20, so 0.2. Okay. And then our random state. Okay. And that one, let's use 24, which is default. Okay. So when you run this one, let's take a look. So what you are basically doing is we want to divide our training data set. We want to divide our data set into training and then testing. Okay. We are trying to say for the testing, we just want 20% of it. Okay. So X testing is 20%, X train is 80%. Okay. Same as Y train is 80%, Y test is 20%. Okay. So we just spread them and then store them in these values. Okay. So now let's take a look at it. So I'll just create a new cell and I'm just going to say X train. Okay. So with X train, we have 120 rows. Okay. When you subtract it's from 150, the remaining is 30. Okay. So we can just check for X test and find out if indeed is 30. So we can just say info. Okay. So we have entries of 30. Okay. Which means we've been able to split our data into the percentage we want. Now the next thing we like to do is scaling of our features. Okay, so we are going to use our standard scaler to do that. Okay, so I'll just come back here. I'll create a variable called scaler or scale. Yeah, and then I'll call my scalar feature a standard scaler. And down here we are just going to say x underscore train underscore scale. Okay, so our train values, we are scaling our train data set. Okay, and we have to call our scalar dot fit transform. Okay, so you can just tap on your keyboard the tab button so that it will just bring this and we can click on it. And then we have to pass in our x train. All right, and down here we have to do same for our x test. So test. Okay, and then let's call it scaled. And we say scalar dot fit transform. You have to pass in our x test. Okay, so now let's run this. Oops. Okay, sorry, my bad. Yeah, so this is it. And then the next thing is let's take a look at how they are now. So with our x train, when you take a look at it, you could realize they've now our values has been scaled, right? When you take a look at this one, so x train here, yeah, so this kind of different from that, right? This is now in an array form. This was in a data frame form, right? And it has been scaled down to certain values, right? So it means we've been able to scale our features. Okay. Now let's move on to the interesting part, which is initializing and also training our model. So here we're going to uh, initialize our model and also train it using k nearest neighbor classifier. So I'll just quickly go down here. All right, so we are going to store our model in a variable called k nearest or knn model. Okay, and we are going to call our k nearest classifier here, for which we are going to give the number of neighbors, so k neighbors. Okay, okay, and the neighbor I will choose for now is just 5. Okay, and then down below we can now call our model. Okay, and we can now fit, which is we can train it using our X scale. Okay, so this is our train data set. So I'm just going to copy that and paste it right here. And also, yeah, have to pass in our Y train. So with our Y train, we didn't scale it. Okay, so we always scale the features, not the labels. Okay, so I'm just going to call that here. And once you are done, we can now run it. Okay, so we've been able to uh, initialize our model and also train it. So now the next step is we have to make predictions. Okay, so we can just call our model, which is k, and then model, and we can call dot predict. Okay, and here we have to pass in our x test scale. So I'm just going to copy this, and I'm going to paste it right here. And when you run it, oops, oh sorry, predict. Yeah. So as you can see, we are having an array form of the outputs. Okay, so we can now save this in a variable. So let's say y predict. Okay, for our k nearest. So, okay, and when you run it again, now we can use these predictions to evaluate our model. Okay, which is the seventh step. All right, so this is how we are going to evaluate our model. We will call our accuracy score and then pass in our X test, okay, which is the actual data set for our testing. And then we will pass in the predicted values for our model. And based on that, we can get the accuracy for that, okay. We also pass in our Y test and then the predicted to also check for our confusion metrics and also get some reports on our classifications, okay. So when you run this one also, you could see we have an accuracy of 0.96667, right? Which is not bad, okay. And we have our confusion metrics here. We have some reports, okay. So precision, recall, F score, yeah, and I think that's it. So the next step, or we can also take a look at the inputs, okay, the input values against the predicted and then also the actual output values. All right, so I have the algorithm ready, and what it basically does is it prints the input features values against the predicted output as well as the actual output. Okay, so I'm just going to run the algorithm, and right here, as you can see, we have our input features, which are these ones. We have our predicted outputs and the actual outputs, right? So the actual is the same as the predicted, okay, which is correct. When we check the second one to the same thing, the third one the same thing, okay. You can even just go to your data set and verify for yourself, okay. So I think the last time when I checked it was around 75. So for the first one, okay, so for the first one we have uh 6.1, 2.8, 4.7, and 2.1, 1.2, right? And when you take a close look at this one, it's exactly the same thing, right? So which means our model is working or doing great, okay? So now we can go ahead and then save our model so that we can use it next time, right? And we can just do that by, let's say, giving the model a file name. So where the name we want to save the model, okay? And let's say I'm just going to say knn underscore model, okay? Yeah, and then the next thing we will do is we have to call the dump, and inside it we will call our model, which is k, and then model, and then we'll call our file name, okay. And once you are done, we can just say you can print a message say model have been saved successfully, okay. All right. Oops. So let's run it and see. Okay, our model has been saved successfully. So we can just go to the directory and check. All right. So this is our KNN model. So we've been able to save our model as well. All right. Yeah. So this is the end of this video. I hope you really enjoyed. If you did, kindly click on the subscribe button, like this video, share with friends, and leave your comments in the comment section. And let's get ready for the next one. See you another time.